Hello dear participants, I welcome you all again here in this certificate course. In the previous lecture, we tried to understand that how can we perform one sample t-test on our data. Also, we tried to understand that how can we read and interpret the results out of one sample t-test. Now in today's lecture, we'll be dealing with the independent samples t-test. So let me welcome you all here in this lecture number 28 with the title Independent Sample T-Test. Objectives of lecture number 28 are as follows. The first objective is to make you all familiar with the procedure of hypothesis testing for independent samples test using MS Excel and S.P.S.S. Once we follow all the procedures and once we get the results in our hand, then we'll try to understand that how can we read and interpret those results. So let me start this lecture with the prerequisites of independent sample t-test. To perform independent sample t-test, what are the requirements that we should fulfill through our data? We should have two independent groups or the samples with us, and the responses which we are collecting, those responses should be on the same variable. Now let's see one example. Suppose we are having two class A is there and class B is there, and there are different students in the class. Now if I collect the information about the marks from all these different students from the different class, this marks, it is the variable, and that variable is same for both the classes. So we are collecting the information on the same variable but from the different samples or from the different two independent groups. So this is the way that if we are having data with us, then we can perform the independent sample t-test. Now what actually, or why should we use independent sample t-test? Independent sample t-test, it is used to find significant difference between the mean of two independent groups or two independent samples. To understand this in a better way, let me take you all to one example, one problem. Suppose for a random sample of 10 persons, diet A treated for 6 months. So these are the persons who are facing the problem of loss of weight, and all these people have been treated with diet A plan for 6 months. Now the data on increased weight after 6 months is collected as follows, and here is the data. So here is the data of 10 persons after diet A. So they are associated with the diet A, and here is the data of increased weight. For a random sample of another 12 person, diet B been treated for 6 months, and here is the data for that independent other sample, that is X2, and here is the diet B. Fine. Now researcher wants to study whether any significant difference exists in the efficiency level of diet A and diet B. In simple terms, we are simply going to compare these two different, say that the independent samples, and we'll compare the mean of both the independent sample, and we'll try to find out whether is there any significant difference between these two or not. So this is the way that independent sample t-test performs. Now how to construct null hypothesis and alternate hypothesis here for the given condition. As you remember, if you remember that in null hypothesis we use equal to sign, and in the alternative hypothesis we use not equal to sign. Moreover, null hypothesis been constructed using words too. How to construct null hypothesis then? Here if I make the statement like this, there is no significant difference in the efficiency level of diet A and B, then it becomes the null hypothesis. Or we can construct in a using different words or different way, and say that average increase in the weight due to diet A and diet B are equal. Or there are different ways that you can construct the null hypothesis, but you should construct your null hypothesis in a such a way that it should represent this thing, that the independent sample 1, there is no significant difference in the independent sample 1 and the independent sample 2, the mean of independent sample, there is no significant difference in these two things. So it should reflect from your sentence or the statement. Now if I come to the alternate hypothesis is nothing but it is exactly opposite to the null hypothesis. So here the statement is there is a significant difference in the efficiency level of diet A and diet B, and symbolically it is again the mean of independent sample 1 is not equal to mean of independent sample 2. So this is the way that we construct the null hypothesis and alternate hypothesis. Now we are going to test this whether to accept or reject the null or alternate hypothesis, and for that we need data. Here is our data. Diet A is presented by 1 and diet B being presented by 2, and here are the increased weight, data of increased weight. Now let me take you to the process of hypothesis testing in S.P.S.S and MS Excel. We'll first go with the S.P.S.S. In S.P.S.S, before going to the S.P.S.S, we need to type our data in MS Excel and then we need to import our data into S.P.S.S. So I'll take you all to the sample worksheet. So here my data been typed here, and it is typed in such a way that here are the diet plan A, and here are the values associated with diet A, and here is diet B and the values associated with diet B. Fine. Now I'll go to S.P.S.S. I'll open my S.P.S.S. Now what would be the first thing? First thing would be I should import my data. And to import data, simply I'll go to file, I'll go to open, I'll go to data, and then I'll go to appropriate file which I just want to import here in my S.P.S.S. So I'll click on this and I'll click on open. Then a new pop-up window comes. I'll simply click on OK. So my data is here in my S.P.S.S. Now the next step would be that I should go to variable view to cross verify the things, to check whether the type and the alignment and the measures, whether the everything is fine, labels, whether the labels are also there or not. So I'll arrange all these things and I'll go back to the data. Now my data is ready for the operation. It is ready for to perform the independent sample t-test. Now what is the procedure to perform the test? To perform test, simply I'll have to go to analyze. I'll click on analyze. I'll go to compare means, and in that I'll go to independent samples t-test. As I click on the independent samples t-test, a new pop-up window comes. Here I'll have to choose two things. The first thing is a test variable. Test variable is nothing but it is a variable on which we want to perform the test. So we just want to perform test on weight. So I'll select this and I'll put this variable here in the test variable. Grouping variable. Grouping variable is a variable which has group within, and this data is associated with these two groups. So diet becomes the grouping variable. So what I'll do, I'll select this and I'll put this variable here in this grouping variable. Now let me do that. I'll simply select this increase in weight and I'll put it here. Then I'll click on diet and I'll put it here. As I put diet here in the grouping variable, this define group get activated. This function gets activated. Now as I click on the define groups, a new pop-up window comes. Here I'll have to specify values for two groups, and here is the limitation of independent sample t-test here in the S.P.S.S. They gives us only two options. If I'm having two groups, then only I can perform the independent sample t-test here in the S.P.S.S. Now here I'll place the specified values 1 and 2 for group 1 and group 2 respectively, and then I'll click on continue. Then I'll click on OK. As I press on OK, I get my output, I get my result in the output window here in the S.P.S.S. Now as we all know that there are two methods, two different approaches using which we can test the hypothesis, using which we can reject or accept the null hypothesis, and those two approaches are p-value approach and critical value approach. Now if I look carefully, here in the first table it is simply the mean of the first independent sample and second, the normal descriptive type of few values are there, and the second table is important one, and it is actually associated with the hypothesis testing result. Fine. Here if I'll find the p-value, where the p-value is located, p-value is located here, that is Sig in bracket 2 tail. Fine, but here I'll find the two different p values. Fine, which one should I consider? It depends on this Leven's test for equality of variance. If you look carefully here, we are having two rows and both the rows are giving the results, somewhat results. Now we are having two options. Either we can go with the equal variance assumed. It means either we can consider the values located here in the first row, or we can consider the values located here in the equal variance not assumed row. Now which one to choose? It depends on this Leven's test for equality of variance. So the first step is to decide which row that we are going to consider, and then the second step is to follow the criteria of these two approaches. So let me first go to the Leven's test for equality of variance. See, whatever value the computed value is here, if it is less than 0.05, then go for equal variance not assumed. If the Leven's p is less than 0.05, go for equal variance not assumed. So if it is less than this, then we can go here for the equal variance not assumed. But if the Leven's p is greater than 0.05, go for equal variance assumed. Fine. Now here in our case, this 0.216, 0.216, it is greater than 0.05. It means this Leven's P is 0.216, it is greater than 0.05. It is greater than 0.05. So the second condition is go for equal variance assumed. So we can continue with this first row. So we have completed, we have we have taken decision that we are now going with the first row. Now in the first row, where is the p value? P value is located here, 0.148, and if the p value is greater than level of significance 0.05, then what would be the decision? You can see that here the p value is greater than this, then do not reject null. We cannot reject the null. And what is our null hypothesis? This is this. There is no significant difference between the diet A and diet B. So this is the simple way that we can conclude the things. But this is one method, that is p-value method. Now if I go for the critical value method, and for the critical value method I'll have to consider this part. So now let me take you to the further slide. Here in critical value this method approach, here is the t-stat, and how much is the t-stat? T-stat is minus 1.504, and suppose if here is my two tail this thing normal distribution curve, and here is somewhere minus 1.50. Fine. Now how to determine critical value? We need to find the critical value. How to find it? This part already we have discussed in the initial lectures on the hypothesis. Fine. Here we have to consider degrees of freedom. They are 20. So I'll go to this number 20. I'll go to this row and I'll go to the column t.025. Why I'll go to this t.025? Because this is two-tailed test, and in two-tailed test the critical value on this side and critical value on this side, it covers 0.025 area, and altogether it covers 0.05. If I go to 0.05, then it tells me that a critical value, a single critical value which covers 0.05 area. But we are working with the two-tailed test. This is all technical issue. Here I just wanted to highlight that here is the degrees of freedom 20 and here is t.025. Then I'll just go to the cell where both the things intersect. So this value is the critical value. Critical value is equal to 2.086. Now if I draw this curve and if I place the critical values here, and if I place the t statistics 1 minus 1.504, then I can take the decision and I can either reject or accept the null hypothesis. Now how it works? Let's see. If I go little further and if I draw the diagram, my critical value, computed critical value is here. Fine, this is your critical value, and the computed t stat is minus 1.504. So it is here, it is located here, it is located in the non-rejection area, that is non-rejection region, and that is why we cannot reject the null hypothesis. What is the thumb rule here? Again you can see that minus cv, that is minus critical value, if it is less than the t stat here, it is greater than this number, because the minus sign is here, that is why this number is greater than this number, then we cannot reject the null hypothesis. We cannot reject the null hypothesis. So this is the way that we take the decision. Then how to interpret this thing? Now here there is no significant difference in the efficiency level of diet A and diet B is the null hypothesis. Symbolically it is shown here. Now at the 5% level of significance, if we compute this p value, that p value appeared like 0.148, and this is greater than 0.05, so we cannot reject the null hypothesis. Now this is wrongly, means some typing mistake is here. Fine, this is 0.148, this is greater than 0.05, so this is also typing mistake. So we do not reject null hypothesis. This is correct statement, cannot reject null hypothesis. Fine. So what would be the result here? We fail to reject the null. We fail to reject null. This is also the another way that we make the statement. Here simply in some cases we can say that we accepted null hypothesis, but technically it is recommended that we cannot say we accepted null. So this thing accepted null is, it is not there. We fail to reject null. So this is the technically correct way that we can go. Anyhow, here I just wanted to highlight that how can we follow the procedure and how to come to the conclusions and how to read and interpret the things on technical ground. Now let me take you all to the MS Excel. So independent sample t-test using MS Excel, how to compute. For that, here is my MS Excel sheet. Simply I'll go to data analysis, and in the data analysis I'll find that there are two options available for me. T-test 2 sample assuming equal variance, and second is 2 sample assuming unequal variance. So I'll choose both the things, but first I'll choose this one, and then as I complete the process I'll get the result, then I'll go for the second option available for me here. So simply I'll click on OK. As I click on OK, a new pop-up window comes. Here I'll have to choose variable 1 range. Then what is my variable 1 range? It should start from this thing and it should end to this 9, because all these data, all these numbers are associated with diet A, that is variable 1. Then for variable 2 I should start from this 7 and I'll end at 17. So this range is actually associated with this second variable, that is independent sample, that is diet B. Now let me select this thing. So I have selected the things. Now I'll select the output range. For that I'll select any this cell, I'll click on this and I'll click on OK. Here is my result. Fine. So this result is for the 2 samples assuming equal variance. Now I'm having the other option also, that is 2 samples assuming unequal variance. So I'll go with this, I'll click on OK. Again I'll follow the same procedures and again I'll click on OK. So my result is here. Now if I compare my result, simply where is the p value? P value is here, p value is here. In both the cases my p value, it is greater than 0.05 level of significance, and if it is greater than 0.05, do not reject null hypothesis. Fine, do not reject null hypothesis. This is the way that we interpret the things. Now if I compare the result of MS Excel and S.P.S.S, then I'll find that, see here, for the equal variance assumed, t statistics is minus 1.50. Here two sample assuming equal variance. T statistics, where is the T statistics? Here it is minus 1.50. Now here the significance level or the p value is 0.148. Here the p value is 0.148. So the results are same. Results are same. This is the way that we compare the thing. This is the way that we interpret the things. And if I come to the graph, in the graph also this 1 point minus 1.504 is located here, and my critical value, it is located here. Here critical that critical value is given here in the MS Excel. This critical value is not given here in the S.P.S.S. That's the only difference. Here if we are referring to S.P.S.S output, then we need to go to the table, T table. Fine. But if you are going with this P value, then there is no need to go for T table. You choose any approach, it will lead you to the same conclusion. It will lead you to the same conclusion. So I hope you understood this part, that how to perform independent sample t-test. Here is the end result, and in the end result here is the null hypothesis, and 0.148 is greater than 0.05, so we cannot reject the null hypothesis. So this is the result. This is the way that we interpret this result. I hope you all understood this. Here are few other examples using which we can perform the independent sample t-test, like efficiency of two different ways of production, efficacy of online and offline mode of education. But the important question, how you measure this? How you measure this is the important question. How you will collect the information on these variables? These are the variables, and this is the important part. Fine. The prices of vegetables in two different cities, consumption pattern of male and female, any two independent samples with the same variable should be same. Like here consumption pattern is a variable for male and for female. They are the two independent samples groups. This is the way that if we are having the data like this, then we can perform independent sample t-test, and it only compares the mean of two different groups, and it tells us, it only try to test whether is there any significant difference or not. That's it. So far the independent sample t-test is concerned. So here we'll stop for this lecture. In the next lecture we'll deal with the dependent sample t-test. Thank you for your kind listening.